In this video, we're going to talk about the exponential function a little bit. So here we have f of x equals 8 to the x plus 5. And again, this plus 5, that extra stuff is always what's transforming it. So that means my parent function is going to be 8 to the x power. This plus 5, you'll notice, is not attached to this x at all. So that just means that my function moved up 5. So if I wanted to draw my parent function here, you'll remember that an exponential always has an asymptote, as you can see over here. We always have a horizontal asymptote, which is written y equals blank, whatever that line is. And that, because of that horizontal asymptote, affects the range. So keep that in mind when we get to that part. But my parent function, again, is going to look something like this. And again, if you just look at your notes, you can see that an exponential parent function looks like this. And since I moved it up 5, that means that I just have to move this up 5. Now that plus 5 is what's affecting my asymptote. Because again, I have a horizontal asymptote for my parent function right here at y equals 0. Well, since I moved it up 5, now my asymptote is at y equals 5. Again, this is my parent function right here. So this guy right here is my f of x. Parent f of x. Asymptote is at y equals 5 because I moved up 5. On my parent function, though, it's always at y equals 0. So now let's talk about domain and range. My domain for my parent function is going to be negative to positive infinity, because you'll see that this graph is going to go forever to the left, and it also goes forever to the right. It goes up, but it does slowly go to the right as well. So that's for the parent function. Now your range for your parent function, again, I have an asymptote at y equals 0. So you'll notice that there's nothing down here in the negatives, so my range starts at 0. Now the reason I have a parentheses right here at 0 is because an asymptote is a line that the function gets really close to, but it doesn't actually touch it, so that's why I have parentheses around 0, because I can't touch 0. So from the bottom, if I'm starting at 0, if you look at your y-axis, this is also going up, and it never stops going up, so the range goes to infinity. Again, domain is left to right, and range is bottom to top. Now if this is the domain and range for my parent function, you'll see that I did not move at all to the right. So my domain is going to stay the exact same for my transformed function because I didn't move to the right. However, like we talked about in the absolute value video, even if it did move to the right, it would not change the domain at all. And the reason it wouldn't change the domain is because my function extends both into the negative portion of the x-axis and the positive, forever in both directions. If you go back to the other video and look at the radical only goes one way, so that's why moving it left to right affected the domain. But since this exponential goes both directions, it does not change the domain. My range, however, does change. Again, my asymptote's at 5, and the reason it's at 5 is because I moved up 5, so that means my range must move up 5 as well, and still goes up to positive infinity. Now if I wanted to figure out increasing or decreasing intervals, well, if I look at my f of x here, you'll see that this is always increasing. So it doesn't decrease at all, so none for that, but it's always increasing along the x-axis. Again, increasing has to do with the x-axis, so it keeps increasing from the negative side all the way to the positive side. And kind of like we talked about with the radical function, the domain and the interval of increasing match. And this is for my f of x function. Let's do another exponential function. So let's say we have f of x equals 5 to the x plus 6 minus 2. Notice the x plus 6 is up here in the exponent. My parent function is just going to be 5 to the x then. Well, since my x plus 6 is in my exponent, that means that part is basically in the parentheses. So that means that I'm going to move to the left 6. Again, it's always the opposite of what we think. And this minus 2 is on the outside, so that means I must move down 2. Now what I'm going to do is show you on the calculator here so you can see that. Okay, so here I have my parent function, which is just 5 to the x power. And over here I moved left 6, right about here, and I went down 2. So notice this flat line here, that's my asymptote. It's starting at negative 2 there because I went down 2 and left 6, so it changed slightly. And again, that's my parent function. So if I write down this transformation, I know that I went left 6 and that I went down 2. And just like we saw on the calculator, I can draw a little sketch here. This is my parent function. Remember, your parent function has an asymptote at y equals 0. And since I went left 6, oh, run out of room, let me draw another one. I went left 6 and down 2, my graph is going to look something like this for my f of x function. So here's my parent function with the asymptote at y equals 0. And here's my f of x, the transformed one, with the asymptote at y equals negative 2. Again, it's a negative 2 because I went down 2, so my asymptote has to go down 2 as well. And if you remember from your notes, that means that my range is going to change. So my domain for my parent function, if you remember from the last problem, is negative infinity to infinity, and the range is 0 to infinity. Now again, because this is an exponential, the horizontal asymptote affects my range. That's why it's a y equals. So because this asymptote's at 0, it's y equals 0, so my range starts at 0. So that must mean for my transformed one, because my asymptote's at negative 2, that means my range must start at negative 2 and go up to infinity. And again, like we talked about in the other video, the other example, the domain, because it stretches both directions, is still going to stay the same, even though I moved left 6. It doesn't matter in this case because of the fact that the function extends into both sides. If I wanted to look at the increasing or decreasing intervals again, if I look at my function here, I can see that it's increasing everywhere. It never stops increasing anywhere. And that's along the x-axis, remember. So it's going to match my domain of negative to positive infinity, and it doesn't decrease anywhere. Since we have a little time, let's look at another exponential where I have a negative. So let's say we just have a negative 2 of x. Well, that means that my parent function is just 2 to the x, because remember that negative flips it. So we'll see how that affects our domain and range. So if I want to draw my parent function, you should know what that looks like by now, with my asymptote at y equals 0, you'll see I did not move up or down at all, so my asymptote is going to stay in the same spot. But again, now it flipped. So if it flipped now, it's going to look something like this. My asymptote is still at y equals 0 because I didn't move down at all, but now it's flipped, so now this is going the other direction. Now the domain on this transformed one, if you'll notice, I'm still extending the x direction both ways, so my domain stays the same. My range is slightly different this time, because now that it flipped over, 0 is going to be where my range stops, and negative infinity is going to be where it starts. So my bottom of my graph is going down here to negative infinity, and the top is going up to 0. And you'll remember from here, the range was 0 to infinity, because I started at 0 and went up. But again, since it flipped, now 0 is my stopping point, that asymptote, and negative infinity is my starting point.